Hello, everyone, and welcome to today's SANS webcast, Prioritizing Security Operations in the AWS Cloud through a NIST Cybersecurity Lens, sponsored by AWS Marketplace. My name is Debbie Gruy with the SANS Institute, and I will be moderating today's webcast. Today's featured speakers are John Pescatore, SANS Director of Emerging Security Trends, and David Aiken, AWS Marketplace Solutions Architect. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to John.
Thanks, Debbie, and welcome everyone. I'm John Pescatore. If you're in the Northern Hemisphere like I am, I hope you're surviving the polar vortex. Here in the Washington, D.C. area, we're having single-digit temperatures. But I think we'll have a great topic to take our minds off the outdoor weather and focus on how we're going to help our business secure operations in the cloud. This is the start of a year-long cooperative effort between SANS and Amazon and AWS. We'll be doing monthly white papers and webinars on topics of interest around this area of making the use of the cloud safe for your business or your government agency. I wrote the first paper, and that's the topic we're going to focus on today, is looking in particular using the NIST framework as kind of a lens, a way to organize looking at the various issues of cloud security related to cloud security and getting those across to management. And that's what we'll drill down on here today. Let me give you an idea of what we're going to do. I'm going to start off. I'm going to go through sort of some of the things I've seen over the years. I joined SANS back in 2013, about 6 years ago now, after almost 14 years leading the security practice at Gartner. And I think I wrote the first cloud security note at Gartner back in 2007. I called it Critical Security Questions to Ask a Software as a Service Provider when that was taking off. And then as infrastructure as a service began to grow back in 2011, came out with the version for IaaS. And over those years at Gartner and over the past 6 years at SANS working with CISOs, seen some success patterns for companies the security programs at companies that have been able to meet business demand to use cloud services while maintaining security levels and in many cases enhancing security levels, but in any event not ending up in the headlines as one of the companies having a breach. So I'm going to focus on that. I'm going to walk through sort of some of the key success patterns I've seen, and we'll go through the main areas of the white paper I wrote. Then I'm going to turn it over to David Aiken from the AWS Marketplace, and he's going to give you drill down on what they've seen and some of the capabilities in their security marketplace, the products out there, and the way customers have been using those capabilities. As Debbie said, we'll leave plenty of time at the end for questions. Enter them into that question window on the right-hand side, and we'll get back to you. I'll also give you an email address where those of you watching a recorded version of this webinar can send your questions later on, and we'll get the right person to get you the right answer. So with that, let's get started. So I've spent my entire career in security. I won't even say how long that is, but over the years, every time a new technology comes around, having a little bounce here on the system. I'll advance the slides so nobody else needs to click in anywhere. Over the years, every time a new technology comes along, whether it was the PC or the internet or now cloud or pretty much everything you can name, there's kind of a predictable sequence we have to go through in security. The very first stage I call cover your assets for a PG audience. Basically anything new, we want to find out if some trusted third party has audited the capability of the technology and certified versions of it. Think back to the first browser, and very quickly FIPS 140 certification for crypto and browsers came out, and banking wanted to make sure they could copy along that. Or if that doesn't exist, we want to make sure somebody else is using it. We very rarely want to be the first adopter of a new technology. We want to look to see, has somebody else charged that hill, and did they survive it? And then we'll do it. So that this level makes the lawyers happy, might make some in upper management happy. It doesn't really make us in security happy, because we know audit and certification and the fact that other people are using it Doesn't mean it's safe to use. May mean we can escape liability, but that doesn't solve the problem or the carnage that'll happen if it's not safe. So next level is to get back the level of visibility into the potential vulnerabilities and threats and attacks that may be hitting the new technology. And you think about what we did when PCs came along and the internet came along, and now the cloud. We're trying to get back to that level of control that we had when we were doing things ourselves, and we're trying to wade through all the claims of this new technology that it's changed the world from security and everything's different now, which is rarely the case. And as a minimum, we definitely want to make sure we have early warning. We know when an event has started to happen or something's starting to go wrong, so we can minimize damage and give warning to management, to business units that, wait a minute, something's going on. We have to take extraordinary action to react right now. And then once we are used to this new technology, then we start saying, okay, now we can extend our existing security controls fully out and bring everything under the covers and get back to sort of our baseline that we've had before the new technology hit. But then inevitably, the new technology enables us to do new things in security. You know, if you think about, you know, for example, a lot of web-based approaches and a lot of sort of social media type things we consider to be risky. Well, now we use things like well-managed bug bounty programs to take advantage of people out there who can actually act as a crowd testing our applications for us. Similarly, there's things out in the cloud that can be done much better than when we tried to do them with more static resources in the data center. And we're going to touch on some of those areas as we go through the use cases here. Finally, by the time we reach this level, some new technology or new thing is going to come along. Quantum computing will be out there, and we'll go back to the cover your assets and work our way through this. The key is doing this at the speed of business, not saying, well, it's going to take us a year and a half to figure this out, because the business won't wait, especially in this ability for things to be quickly hosted out in the cloud and just simply go around security and IT completely. So when we look in particular at infrastructure as a service, which has really exploded in use here over the past couple of years, you know, there's many ways where in some ways it feels similar to just outsourcing data centers, whether it was old colo type hosting or you know, fully managed hosting where a company ran all the resources and so on. And some things are similar. You know, the bottom line is there are professional cloud hosters, there are professional infrastructure as a service offerings that are actually run way more securely than the average data center. But that doesn't mean that every provider out there is run more securely than you can do it yourself. The key is knowing what your baseline is, and that you have an established level of security protecting your on-premise capabilities at the data center. You know where your gaps are, and from there you focus as much as possible on influencing the business side or the IT side to choose the most secure cloud providers as a starting point. And we'll touch on that. Any sort of outsourcing, any sort of cloud use, the very first difference is we don't have the same visibility into assets and changes and what's going on that we used to have. Doesn't mean we have less. In some cases, we might actually have more, but it's different. And the old ways of doing things have to be extended to work and to include regaining that visibility and ultimately a level of control of what's going out there on our critical business applications running out at infrastructure as a service. Another difference compared to sort of colo hosting or any sort of the old hosted ways of outsourcing data centers is the virtualized environment that's running underneath the infrastructure as a service offerings, where we run our servers and our applications, has its own set of security primitives built in at a bunch of different levels. And taking advantage of those can help lead us to those new capabilities, and we're going to touch on that. The final point made in the white paper quite a bit was that most of it, almost all of us, are running security products locally to protect our on-premises data center, whether those are firewalls or endpoint detection and response or data security or SIM products or whatever. In almost all cases, the best approach is going to be where third-party products are added to the infrastructure as a service offering out in the cloud to use those same security products. Minimizes the problems of needing double training for using different types of products, minimizes the problems of gaps, minimizes different security policies getting worded different ways for products. So heavily weighting products that you're already using, and can you run those as software products out on infrastructure service offering is going to be very key, and you'll see make that point over and over again. So in looking across this, here's the diagram I've sort of built up, what we're trying to do to sort of make our security architecture and our security processes work seamlessly across our on-premises environment, as well as things that are going to be hosted out in the cloud. So in the gray in the middle there, you see the traditional, we're running Linux or Windows, and there's some data being stored in Oracle or, SQL Server, whatever type databases. On top of the server operating system, running business applications for the logic end of things and the web presentation tier. And then there's some host-based security we were typically running. Along comes infrastructure as a service offerings like Amazon AWS and others, and they have some of their own security services I mentioned that operate at a number of levels. At that virtualization level that's really underneath the server OS images we're running and underneath the data storage side of things that we're running out there, but also at the very top, things that are running in virtual networks and virtual private networks and the like between our server instantiations out there and the direct connection to the internet. So the goal is first to extend our enterprise security controls and services out to the cloud, but also to be able to pull in the capabilities that are baked into the IaaS infrastructure as security services that we can take advantage of and essentially magnify our capabilities out there. So some of those patterns I mentioned, I've seen over the years. I made the decision to come to SANS 6 years ago because I began to see how important the people side of the equation was over the years. And in the cloud area, working with CISOs in this topic, pretty much everybody finds they need their security operations skills to be plussed up to what's different in the cloud. It's not a whole different security problems. The primitives of confidentiality, integrity, availability, the critical security controls and the like are still key, but it's making sure the skills have been plussed up to understand what is different about security and virtualized and especially infrastructure as a service environments. Sort of a seminal event, like the first canary into the mine shaft for infrastructure as a service is often when the dev test group says, wow, we could spin up dev test environments and tear them down and save money and really do this a whole lot better than trying to maintain a dedicated dev test environment. If the security team is part of that first test, yeah, please, anybody clicking, please do not click on the screens or hit the up-down buttons there. Security team being part of that initial migration is really key. There's a lot of things that get learned there. There's a lot of opportunity for security to be part of the solution, working with the IT and the biz apps area, and reach that parity of doing things out at IaaS at least as good, if not better, than how we do them locally is key. And almost everybody that starts using IaaS is going to end up at some point in the future doing hybrid cloud, where there's applications that can sort of cloud burst out to use cloud resources or run on-premise and do that seamlessly. And working with dev test on that initial use of IaaS is really key. So if you haven't passed that milestone yet, try to get security involved in that milestone. The bad guys attack every new technology, and they analyze every new technology and attack it just as we analyze it and try to secure it. So we will see cloud-specific attacks and attacks against cloud infrastructure and cloud providers and the like in the future. Right now, we mostly see them exploiting badly managed cloud services, and we're going to drill down on that later. But it is key to say, how am I going to evolve the way I'm protecting these cloud-based services as new forms of attack do arise? So the best starting point for this, and where spend time in the white paper, is to make sure you have a justifiable starting point. Typically, that means using some industry-accepted framework as a way to say, here's the things we need to do in security, here's the main elements we need to do a risk assessment and gaps, and then apply security controls, and it's this defensible thing that's industry support. So you see the number of frameworks up there that are commonly used for that. We've focused on the NIST framework, which in the United States certainly and even globally has become one of the most widely adopted ones in use, and also has a mapping to every other framework out there. So one of the great things NIST did with the cybersecurity framework is map to every other possible thing out there. That doesn't really matter what you use. You can use the NIST framework as a great starting point. The security group, where possible, should be involved in the selection of cloud service providers so that security criteria are getting in there as part of the decision. And there's a government program I'll show you in the next slide called FedRAMP, where they do require cloud service providers to submit lots of paperwork and have lots of testing happen, and they do certify and approve cloud services for government use, and we're finding rapid growth there in private industry saying, yeah, we will only allow our businesses to choose services from that FedRAMP list. Like the old commercial about potato chips, nobody ever just uses one cloud service, so every time you're thinking through this problem or scaling out something, think about how you're going to make that work across multiple cloud services. So here's the diagram of the NIST framework. It's we'll give you a link to the overall documentation as we at the end of the presentation. But what basically it does is have the 5 major functional areas you see there: identify, protect, detect, respond, and recover. Identify and protect are kind of the proactive steps that we can do things before an attack happens to either avoid vulnerabilities or mitigate them and hopefully stop attacks. Obviously, detect, respond, and recover. Bad stuff has started to happen, but we want to minimize the damage. And we all know nobody can stop 100% of the things 100% of the time. We'll be using all these phases. And this breaks it down into these 22 subcategories you see below there and 98 other primitives down there. The biggest value of this is getting across to management, CXOs, boards of directors, what our strategy is in security, why we're doing things, why we need to change, why we're asking for resources, why we're asking for the business units to do things slightly differently, and it's a great thing to point to for that. So here's the FedRAMP program. One huge benefit, I tried to find out how many cloud service providers are out there. Nobody seems to know the total number, but if you look in the Wikipedia, they have at least 266 listed as far as infrastructure as a service, not even counting all the application or software as a service ones. Well, on the FedRAMP list, as of the latest, I did this check of their website last week, there's 127 authorized services that range from software as a service to infrastructure as a service, with 70 more in process and 13 just getting ready to enter the testing pipeline. So you can have does this mean these are invulnerable? No, but it means they've gone through a level of inspection, a level of due diligence, and that if the security team can say, at least please start from the FedRAMP list, and we will, on the security side, sort of be plussing up the skills and our ability to extend security out to these providers. But what I really like about the way FedRAMP is doing this, they're requiring all the cloud service providers to provide continuous monitoring capabilities of operational visibility to the government, not just at the application level, not just at your servers you're spinning up, but at the virtualization level as well. And so whether the government's doing anything with this data or not, looking at these floods of data coming from cloud service providers, we don't control that. But the fact is that most of these cloud services, we also get to take advantage, the ones that are certified for FedRAMP, we get to take advantage of that visibility to help us move down that hierarchy. I just went through a few slides previously. So it's a good starting point, and it's a good starting point especially for thinking about how we're going to get our security operations center, our SOC processes, to extend out to business services running out at infrastructure as a service. Chris Crowley is SANS' lead instructor in the SOC management side of things, and here's our standard triad of to implement efficient and effective SOC processes, we'll need a mixture of people with the right skills, processes that are well-defined and repeatable and hopefully lend themselves to some level of automation, and then technology, software, and products that will implement the security controls across identify, protect, defend, respond, and restore, and so on. So we need that continuous monitoring visibility so that we can feed this and continue to have our SOC processes secure biz apps even as they move out to run at remote places like infrastructure as a service. So there are some areas where the specific things to focus on within security capabilities as your business organizations start running applications out at the cloud. Certainly that visibility, that identify and asset management side of things is important in the on-premise data center. It's even more important out at things like infrastructure as a service, where new servers and new instantiations can be spun up rapidly. Having standards for configurations, having monitoring of when servers spin up that are not in the right configuration, and extending vulnerability assessment out to this environment is obviously key. All the things we do to mitigate vulnerabilities or minimize our attack aperture, like firewalls, intrusion prevention, endpoint anti-malware, and you'll see we'll drill down on application security, hopefully minimizing the number of vulnerabilities in applications we write are key. Data security brings an additional level of importance when we start to think about infrastructure as a service. There's some issues about physical location of data. There's issues about breach reporting of data when it's stored at third parties, that if we can make the beachhead of encrypting sensitive data when it's stored, we can start to mitigate the costs and the risks of those potential exposures if the data was encrypted. And we'll touch on that later as well. There are also, as I mentioned earlier, cloud-specific capabilities. Each infrastructure service provider has security primitives you can take advantage of, and there's new products out there, cloud security platforms, that enable you to use those in a manageable way. One key issue is you're going to have a cloud service admin just the way you have server admins today. Some of the worst disasters in use of the cloud have been because admin accounts have gotten phished and gotten compromised. The provider's perfectly secure, but our own admins got phished, gave away their account privileges, and bad things started to happen. So it's really key to try to make a beachhead of we say we require two-factor or strong authentication on all admin accounts. When we go out to the cloud, we need to really make sure it happens. And every major cloud service provider supports this. And also there's many capabilities and many new functions out there to minimize privileges and provide sub-admin privileges, so administrators can only do what they need to do and can't see across the entire running of the IAS offering. So in the white paper, I focused on the three most common scenarios businesses run into in cloud. The first I mentioned is when DevTest tries out infrastructure as a service. The next one is when a biz app is launched from infrastructure as a service or moved from on-premise out to run out in the cloud. And then ultimately the hybrid cloud scenario, where the apps can sort of migrate based on best cost and best effective delivery issues and security supporting that. So we're going to drill down on each of these, and then I'll be turning it over here to David at about the half-hour mark. So in the white paper, I went through each of these scenarios and took those NIST functions, those 5 functional areas, and laid out under the due diligence column you see there, what are the security functions, security controls that should be deployed as part of that offering. And you'll see this is where DevTest is moving out there. Getting application security testing tools and products baked into the DevTest environment is key. It's key on the on-premises as well. This is an opportunity to make sure we're saying this is a due diligence thing if you want to do DevTest out in the cloud. This isn't some advanced thing we need to do. Then you see the standard things I mentioned before: configuration management, sys management, vulnerability management, firewall, and skills training. Data masking is a key one here. The DevTest guys will always need some data to test the applications against. It should not be live customer data out in a DevTest environment. It's risky to do it when it's on your premises. It's irresponsible to use live customer data when we're running DevTest out in infrastructure as a service. So there's a lot of data masking, obfuscation tools that should be baked in to that plan. And under detect, respond, and recover and due diligence, you see pretty much the standard things. We need to have IDS to know if something bad happened, SIM to aggregate all the logs and do both the log monitoring, reporting, and correlation and alerting we do. Bad stuff can always happen. Our incident response services and trouble ticket systems need to roll out there. DevTest environments often have different needs and different ways of backing things up, since they're mainly concerned with backing up applications versus data. But some level of backup needs to be baked out there as well. We start looking at the lean forward or advanced side of things. This is if your risk assessment says you're using applications out there, you have above average or above due diligence needs of security. Things like governance, risk compliance extending out there, the ability to have penetration testing services done against the running dev test environment would be added at that level. You see encryption, data encryption, which we'll drill down in a little bit later, and then moving from intrusion detection to intrusion prevention to protect the dev test environment, not just to detect when an attack happens, to prevent against it and keep things running. Then you start, and there's strong authentication, as I mentioned before. Then you start seeing some of the capabilities that are baked into the way cloud systems are provisioned and managed and the whole virtualization works, the ability to use containers and other cloud-based constructs and have secure images rolled out and make it so that sysadmins cannot spin out servers that are not based on the secure image. Some really cool things that can be done to advance security in that way. And then some of the standard things under respond and recover that you would want to roll out to a higher risk or higher value environment. So the next I talked through most of these things about making sure it's not live test data out there, AppSec being built in, and so on. One last point here. Another thing you can test out on that dev test environment is the ability to rapidly test patches. You have a full production environment with safe test data. Many organizations are saying, instead of taking 3 days to test patches, I can do it in 3 hours now on this dev test environment, and we can QA patches much faster and shorten the time it takes our change windows and also push the patches out faster, which is obviously a big gain for both on-premises and cloud-based systems. So that second scenario where business applications are moving out to the cloud, this is now production applications with production data. So at that due diligence level, things like awareness training against phishing and other issues that are going to happen, especially those sysadmins that are cloud admins get added to the mix. Denial of service filtering. If you can't reach your cloud apps or your customer can't reach your cloud apps, then you failed. So you need to think the denial of service filtering both for managing what's running out at IAS and for your customers accessing them. Many of the other things don't change when it's a business application moving out there at the due diligence level. When you start looking at the advanced or that lean forward level, as business applications start and multiple business applications start being run out in infrastructure as a service, those cloud management platforms come into play, I think, in a much bigger way. And you may now have security products like virtual firewalls or software versions of your Checkpoint or Palo Alto firewalls running out in the cloud. And you need tools like firewall policy management to be able to seamlessly run the virtual one or the policies that are out in the virtual environment and policies that may be on physical environment in your on-premise, physical firewalls on your on-premise environment. And once again, I probably talked through most of these things, talking you through the matrix. But you see it summarized here in the slide there, and I can drill down if we have any questions during the question time frame. So the final sort of holy grail is that hybrid cloud environment where the full promise of infrastructure services realized and things are running both in on-premise data centers and out in the cloud. It doesn't look tremendously different than the biz apps out there. I think a little more premium on those network policy or firewall policy management tools, some concepts like cloud authentication and cloud access service brokers or CASBs come into play that we don't get into at this level. But it's really sort of maturing your use of the cloud and making sure everything is seamlessly integrated from the security architecture across the two environments. So it does mean looking at our playbooks, looking at some of the things that might be done differently on those local security controls that run in the IaaS infrastructure versus the one we add on. But you see here, that those firewall or network policy management tools, I think, are the real step up here to help us in security move as quickly as business and IT are going to move in a hybrid cloud environment. So to sort of drill down on a few other areas, there are some operational considerations beyond the product choices when you have to think through. For doing penetration testing against what you have running out at a cloud provider, you usually have to coordinate with the infrastructure as a service provider, because they will often detect an attack, and if it's against their customers on their infrastructure, they may often react in ways you don't want them to do. So most cloud providers have ways of coordinating you doing vulnerability scanning or pen testing. All infrastructure as a service providers have some kind of service level agreements that have some amount of downtime that's acceptable, and there may be change windows that are based on that, and things that are ways change windows are done differently because of those SLAs. The security software you're used to using on on-premise appliances, the licensing models may be different. They may be based on throughput and data usage versus number of endpoints and the like. And a very important thing, if worse comes to worse and some incident does start to happen and we need to disconnect the cloud service from everything, how do we do it? How do I pull that cord? How do I push that giant red button? This will be different for each cloud service provider. They don't adapt to you. You have to adapt to them. So if you need to remove all admin access or lock everything down and freeze the state and to enable a forensics investigation, you need to know how to do that in advance. You need to have updated your playbooks to do that, and you need to have tested that out. Run some tabletop exercises or test runs on the dev test environment to simulate something bad happening and the reaction going in the right direction. So the bottom line is there are a lot of security capabilities built into the virtualized infrastructure of most cloud environments, but very rarely will that be the total solution. Almost invariably, across all those 5 phases or functions of the NIST framework, you're going to need to extend the types of third-party products you're using around your on-premise data centers out to run into the cloud. And trying to use common products across the two, I think, is really key to both maintaining that effectiveness and certainly being able to do it efficiently and not have to require high levels of staffing and new resources to pull cloud-based systems under the security covers. So the final thing is big gains to be made if we can start encrypting stored data. And the cloud, as you move out to the cloud, that's one key transition point to work in there. How can we start making progress in encrypting cloud data and stored data? In many cases, it's actually easier to do out in the cloud for a variety of reasons. So the papers will be out there in the SANS reading room. I run a program called the What Works We Do at SANS that has a lot of examples of both cloud security solutions and others. There's links to both the NIST cybersecurity framework, the FedRAMP standards, and the listing of who's out there, who's certified. And then there's where you'll be hearing about the AWS Marketplace next from David and the capabilities there. We figured we'd give you a link there. If you are listening to a recorded version of this and you'd like an answer, for me especially, you can send it to q@sans.org and we'll get you that answer. So with that, let me turn it over to David for some great drill down.
Excellent. Thanks, John. Hi, I'm David. I'm a solutions architect at AWS. I've been working in cloud since 2005 onwards through various cloud providers. And what I want to do is dig a little bit into some of the topics John's covered and how AWS and AWS ISV partners can help. Hey, and this slide's transitioned. Fantastic. So let's start with a quick reminder about how AWS views security in the cloud. First, security is job zero for AWS, and we've got many of the same security isolations you would find in a typical data center. Now, we do have a shared responsibility model where AWS is responsible for the security of the cloud, and you are responsible for the security in the cloud. Now, I'm sure most of you are aware of this, and if not, there's plenty of material on the AWS website to get you up to speed on that. Now, the shared responsibility model is important because it does actually impact how you might apply frameworks in a couple of ways. And probably the biggest example I can give is around physical asset management. Since AWS is managing the physical infrastructure, it's not something that you can that you have to directly do something with or responsible for. Now, for security architects and engineers and analysts implementing security solutions on AWS, we've got a wide range of best practices, encryption, AWS native services to help you align with the NIST CSF core functions and achieve security in the cloud. And the integration of these services as part of your enterprise technology can help you build automated, innovative, and secure solutions to strengthen your cybersecurity posture. As an example, we've got tools like AWS config and resource tagging that's going to help you see exactly what assets your company is running at any moment within AWS. Something that's pretty hard to do on premises. We also have AWS Systems Manager to ensure your fleet is up to date. Now, there are other AWS services that allow you to protect your infrastructure and detect anomalies. Take, for example, Edmunds, the car shopping website, which has a lot of internal customer and partner data stored on Amazon S3. Edmunds wanted a way to classify the actual uses of data and to verify if this was in compliance with their data access and use policies. And Edmunds took a look at Amazon Macy, which is an AWS service that uses machine learning and natural language processing to classify data, understand its everyday usage, and alert administrators to anomalies. So now Edmunds can tell where their important data is, and they can focus their attention on that. Now, with AWS, many operations that previously required humans to actually go physically move things around are now implemented via APIs. And this is helping AWS and partners build solutions that can automate the respond and recover categories of the NIST CSF in what was previously, as I mentioned, a people-heavy process. There's many AWS native services have been accredited against third-party assurance frameworks such as ISO 27017 for security, 27018 for privacy. We also have SOC 1, 2, and 3. Customers can build PCI and HIPAA compliant workloads on AWS, and AWS has the public sector certifications such as FedRAMP at the moderate and high level for federal government systems, as well as SRG Impact level 2, 4, and 5 for DoD systems. Healthcare and life sciences, amongst others, are covered by ISO 9001, and AWS has recently had its service alignment with the NIST CSF validated by a third-party auditor, Kratos, which was back in September 2018. Now, what they did there was each of the NIST CSF core subcategories was assessed and rendered to meet one of the following criteria. It was either mapped to an applicable AWS service, it was identified as a customer responsibility, remember the shared responsibility model, or it was designated as satisfied through a third-party certification, which we've just talked about. The other thing to note is AWS offers a set of quick starts, which are readily deployable CloudFormation templates that help you set up an environment and capture all the best practices. And we have guides for the NIST SP 800-53, revision 4-122 and 171. So if you want to build a standardized environment that meet these requirements, it's a few mouse clicks to kind of get going. Now, as well as the AWS services, we've got a selection of third-party tools from AWS Marketplace that you can also use to improve your security. And if I look at this, there's probably several hundred ISV security solutions available in Marketplace, and some of them are shown here. You should recognize some of these ISVs from your on-premises world, right? So companies like Trend Micro, Barracuda, Symantec, they've all been updating their portfolios to work with cloud and, both enhancing the native AWS capabilities as well as bringing a consistent view across cloud and on-premises environments. These solutions have been well architected for AWS, meaning that they can be deployed across multiple AZs and make best use of the native services. For example, the Barracuda WAF can be deployed in an AWS auto-scaling group. And what that does is it allows Amazon EC2 instances to be deployed when traffic rises and removed when traffic is reduced after a spike. Now, we also have newer born-in-the-cloud ISVs like Dome9, and they're springing up to solve some of the cloud-specific security challenges, such as visibility across clouds. These solutions typically can be integrated with AWS services and other existing technologies to help boost your security posture. So today we're seeing a lot of organizations using security solutions in AWS Marketplace to support a diverse security operation priorities. And to show you what I mean, I'm going to share a few customer stories that have made and solutions that have made a real impact to customers. So let's go back to Dome9 for a moment and talk about how they helped Western Union gain operational insights into AWS. So Western Union serves over 150 million customers across 200 countries and territories. They execute transactions in about 130 currencies and provide services through over 100,000 ATMs and kiosks worldwide. So, no small footprint here. And moving to cloud, the Western Union developers were quick to realize that they could do things much quicker when it's an API call to get a new database or a new EC2 instance up and running. But it was proving, challenging for the security teams to keep up with the pace of innovation that you can drive there. Now, Western Union was training developers on their own security framework, and the company needed cloud-specific security people and needed them to be embedded into the development and architecture teams. It's not something that you would typically, try and keep separately. You need this tighter integration, particularly in a DevOps world. Now, Western Union also realized they needed a better tool for visibility. All the data they needed was available in the AWS console and the AWS logs, but they wanted a holistic view across multiple AWS accounts, multiple regions, and VPCs. They also needed to support some of the new services such as CloudFormation and serverless architectures with AWS Lambda. Now, they didn't have a ton of resources to go create a whole bunch of custom scripts and algorithms and things, so they turned to Dome9. Now, what Dome9's allowed Western Union to do is integrate security into the development process and provide a lot of visibility across multiple accounts. Dome9 brings in all of the configuration and logs across multiple AWS accounts and gives them insights into the security posture. So, common problems like S3 buckets open to the world or EC2 instances being exposed aren't a problem anymore, because Dome9 is going to not only detect these, but you can also trigger automated remediation as well. Dome9 gives them this visibility into the identity system within AWS, as well as password policies and a whole ton of more. So Western Union can now lock down, prevent unapproved AWS regions from being used, detect and block security group changes, provide alerts on high-risk changes such as port 22 being open to the internet. So now they've pretty much have all the operational insight at scale much more efficiently than previously. So Western Union is able to easily secure and grow its money transfer website while freeing up the staff to work on other business problems. US-based outdoor retailer REI, they wanted to extend their security posture to include edge protection of its AWS networks as it migrated applications across. REI's organization comprises of about 400 people across security application and core infrastructure and DevOps. And previously, one of the areas where they lacked was a solid investigation workflow that included its AWS deployment. And, teams would typically spend up to a week logging in different accounts, using different tools to try and aggregate data across all these different systems, including some of the on-premises systems as well. So REI wanted to create a secure way of ingressing and a migration path for data and applications moving into AWS. So they decided to do a POC. They wanted to centralize log management and edge protection services across the teams, provide a common framework to work within, and went for a combination of AWS Shield and GuardDuty, which are two native AWS services, along with Splunk Cloud to give them that insight into all of the logs across VPCs, across load balancers, across guard duty logs, and everything like that. And by bringing all of this data together, REI gained its biggest advantage in securing the edge in a repeatable way, because it's part of the new dev process. REI also uses Amazon Guard Duty, AWS Shield to manage DDoS protection, and the AWS WAF to meet its IDS and security requirements for blocking common exploits as well. Guard Duty add-on for Splunk allows them to bring all of that information into the same kind of dashboards and provide that operational context for detection and rapid investigations. So our REI has integrated this solution into their DevSecOps practice, which I think is pretty cool, utilizing things like Terraform and Jenkins, some of the tools you might be familiar with, to make sure the same standards applied across all of the new accounts or VPCs. So now they have real-time end-to-end visibility, closing all of those potential security gaps as they move across to AWS. As always, my kids have a bet with me to see if I can get something weird into my talk, and this time it was like, Dad, get Pokemon into the talk, so here we go. Pokemon Company International is actually responsible for the brand management, licensing, and marketing of Pokemon, including Pokemon Go. They have a global audience numbering in the hundreds of millions, and obviously detecting security vulnerabilities, protecting its environment is one of the key tasks for the Pokemon company in maintaining trust for its customers, which are basically children and parents. The corporate side of Pokemon, like most enterprises, is a combination of on-premises and cloud-based systems, and the customer-facing platform mostly on AWS. Now, Pokemon uses EC2 to provide the compute and partnered with CrowdStrike to gain visibility and establish baselines for Pokemon's AWS platform. Now, CrowdStrike, if you're not familiar with them, provides endpoint protection, and it integrates antivirus, endpoint detection and response, IT hygiene, and they have a 24/7 kind of managed hunting service available, and it's all part of the one package and available via a pretty lightweight agent in there. Again, like countless other companies, Pokemon utilizes DevOps to move fast, but introduces the risk of DevOps engineers maybe deploying things without all the correct tools. So part of CrowdStrike's Falcon Discover platform is the ability to detect when EC2 instances don't have the agents installed, and actually allows you to then go remediate against that and put the agents in there. So CrowdStrike now basically is allowing Pokemon's analysts to seamlessly pivot between an on-premises and AWS, because they're managing both environments with the same set of tools. And as John mentioned, one of the keys to being successful is to go use all of your existing practices and your existing tools where applicable, and apply those to your AWS footprint. And I think a good example of that is with the Alberta Motor Association, which is a non-profit membership organization in Canada, Alberta's province, funnily enough. And what they do is they wanted to make sure that their AWS hosts applications were protected against attacks by using behavioral analytics, proactive bot defense, application layer encryption of sensitive data, and so on. And as I said, like most enterprises, they have a combination of on-premises and AWS cloud infrastructure. So they moved to AWS basically to increase the dev speed, and they were already using F5 on premises. And what they quickly realized was they could use the same F5 WAF to provide a similar endpoint protection in the cloud. And they were able to consume this from Marketplace and get things up and running pretty seamlessly, pretty quickly, and apply the same security policies across on-premises and within the cloud infrastructure. So they're not only using the same set of skills, they're using the same set of tools, which is obviously going to make them be able to ramp up and secure the environment a lot faster on there. Sorry, there's a little delay between my click and the screen changing. So let's talk a little bit, we've talked through a couple of examples here, but why Marketplace? So AWS Marketplace is a digital software catalog that makes it easy for you to find, buy, deploy and manage software that runs on AWS. And it has a great selection of security solutions from hundreds of ISVs spanning security, infrastructure security, logging, monitoring, as well as identity access control, data protection, and a whole bunch more. Software solutions in Marketplace incorporate AWS best practices and are ready to run on AWS or are provided by a SaaS service. Marketplace gives you the same on-demand or contract pricing you have for other AWS services to ISV products. So for example, you can deploy a Marketplace AMI to EC2 and only pay for the software you're using at an hourly rate. And this is very different from buying the on-premises software model where you're buying a license over a period of years or a number of seats. Within AWS, to give you that flexibility, you can actually consume the software and pay for it hourly. You can also switch to annual rates, so you can have a mixture of things that you're running 24/7, and then to handle elastic workloads, you can use the hourly pricing. A great example with the Barracuda WAF we mentioned earlier, if you're scaling up between, say, 2 and 6 instances, you may take out 2 annual licenses and save some money there, and then pay for the 4 elastic instances on an hourly basis. For SaaS services, you can pay either upfront with a contract or monthly with 1, 2, or 3-year terms, and there's also an on-demand model as well. Now, all of the charges are going to appear on your AWS bill, and it's that certainly helps with your procurement processes. You already have a billing relationship with AWS. You just need to review and accept the license terms for the software, and away you go. And because it appears on your AWS bill, you're going to get integration with things like AWS budgets, Cost Explorer, and all those kind of things. Last but not least, Marketplace is supported by a team of humans. We have solutions architects, security experts, product specialists to help you with your security needs and do investigations and POCs and that kind of thing. So you're probably wondering, this is awesome, how do I get started? Well, first of all, we've covered a lot of principles with John and the white paper. We've given you some examples of how AWS services and partner solutions can help. So I encourage you to go on AWS, go into AWS Marketplace. Most of the solutions we've talked about have free trials, so you can do a quick POC. Because all of the software is pre-packaged, you can do a POC in your lunch break. You can spin up CrowdStrike or Barracuda, run it for a few hours, do a POC and shut it down, and it'll cost you a handful of dollars to go do that. The next thing we want you to do is go talk to your AWS solutions architects. Most of you probably have some sort of relationship with AWS, and you can get in touch with your architects there. And finally, don't forget your trusted partners such as Optiv, who can help you implement NIST CSF on AWS. So just to recap before we jump into questions, one of the key things is, make sure you understand the key pieces of your workload. And I think the NIST framework and certainly the white paper really helps kind of position all of the different pieces as part of that. And remember, there's some things that are very different in cloud than on premises. Make sure you've got a good handle on, what those are and how you need to skill up your security teams, adapt your processes, controls, and third-party products. I'd ask yourself, how far are you away from practicing best practices? And a great tool to use is, as John mentioned, is having a framework, and NIST CSF is a great place to start there. And lastly, look at both your cloud native and third-party controls and make sure you're not, reinventing the wheel. There's a lot of tools and technologies that you can instantly apply to cloud, as well as some new challenges around some of the cloud services that are new and maybe don't have an equivalent on-premises equivalent service. And don't forget, AWS Marketplace can really help you get started with that. And with that note, I'm going to hand it back to John.
Okay, thanks, David. We've got a whole bunch of questions. Let me see how many we can squeeze in here before we run out of time. I'll sort of alternate between the ones for me and the ones for David. First off, the white paper I wrote that I mentioned hasn't been published yet. I'm late, okay? So we had to do the webinar before the paper's published. Everybody who's registered for the webinar, you'll get notification when that paper is published. The one some people mentioned in the questions there, AWS had already put out a previous white paper sort of tying the built-in security functions within the AWS platform to the NIST framework. The one I wrote is more at the higher level, sort of what we went through in the presentation here. David, let me ask you this question. Whoops, just another one came in and scrolled by the one I had there. The question was, how does what you talked about here, the AWS services across the NIST CSF, relate to the Security Hub view recently announced by Amazon? Hope you're on mute, David.
Yeah, it helps if you unmute. Yeah, so Security Hub is a new service that we announced at reInvent back in November, and it's really designed to give you a view into the security of your AWS footprint. But one of the really cool things about it is, AWS really works with partners very well, and we discovered that, hey, we've got partners like Splunk who already have a ton of data that we want to be able to bring into the Security Hub. So there's a lot of partners surfacing data now within the Security Hub, such as CrowdStrike and Splunk, so you can get a single consolidated view across your entire footprint, whether that's native AWS service or through a partner offering.
Okay, the question for me, why am I recommending try to steer things towards services that are certified by FedRAMP? It's a government thing, takes a long time often to certify things. There's other faster ways. A lot of the other certifications you see out there, SOC so-and-so, PCI so-and-so, are often self-assessment questionnaire driven or purely compliance driven. There's not a level of testing. There's not the requirement for the continuous monitoring outputs that see in FedRAMP. So there's government services get certified by FedRAMP, but like AWS and others that are only for government use, but they're these providers that got on the FedRAMP list have similar commercial services that meet those requirements. So where possible, I do think it's a very powerful starting point. I'll take a question for you, David, here. We had another one. It was a question here about how do you evaluate security tools offered in the marketplace?
That's a great question, John. So there's a couple of things we do. And first of all, we have a catalog team of security specialists who come from the security industry, usually have a good background either within security teams or have come from security vendors. And they do part of the curation of some of these tools that we talked about within catalog. So, we have a partly curated catalog of security tools, but we also have a lot of startups coming along who are building new security platforms, and they're welcome to come and list on Marketplace as well. Particularly in the security area, we have a team of solutions architects that are looking at the solutions and making sure that when you're deploying software from Marketplace onto AWS, that they're following all of the best practices, right? So they're making sure that, out of the box, that there is strong security within the instance that's being deployed. They're making sure that, they're not opening up too many ports to the wrong kind of locations. So, no port 22 is being opened. Passwords are being generated that are unique. And in particular, a lot of the security vendors are now working on high availability solutions and automatic kind of remediation. So we're helping a lot of those vendors integrate with AWS so that out of the box, again, you can deploy something and know that it's going to keep running in the face of some sort of disaster.
Okay, I think we squeezed one more in here. I mentioned new attacks coming along and cloud-specific attacks against infrastructure providers. Well, it's not just against infrastructure providers. When you think about things like insider attacks, for example, it's pretty hard, not impossible, but pretty hard for an insider to roll a new server into the data center. With VMware, it's obviously easier to spin up processes, but in the cloud, it's really easy to spin up new services. So a malicious insider is certainly enabled, but also attacks against the APIs, the management APIs of cloud service providers. If those aren't done right, those can be used vulnerabilities, things like man-in-the-middle type attacks where IT thinks they're talking directly to the cloud services, but they're really talking to a man-in-the-middle. We've seen vulnerabilities like Heartbleed and other sort of open source and other type tools. In many cases, cloud service providers get fixed more quickly, but in other cases, smaller cloud service providers many have taken a huge amount of time to fix some vulnerabilities, so this enables attacks against the cloud infrastructure. Sort of side channel type attacks, can one tenant detect what's going on by another tenant of a cloud service based on side channel effects, whether it's error messages, or delays in response times. There's a lot of these have been tried and in some cases succeeded, and in many cases the better cloud service providers have built in new forms of protections or made sure their APIs are secured. But for us, it's getting back to, it's making sure we have the level of visibility and control so we can notice if something goes wrong to what we're doing. So I think with that, we're right about at the end of the time. Let me turn it back over to Debbie for some final words and pointers for additional information.
Thank you so much, John and David, for your great presentations, and to AWS Marketplace for sponsoring this webcast and the entire Security Operations in the Cloud series.